Distributive property. In the last lesson we just did, we saw the important properties of addition and multiplication, the commutative and associative. The last of the three major properties combines them, and it's the distributive property. So consider the product of 4 times 15. So we're going to evaluate using the standard algorithm, which is the way that you've always done it or the way that you may have originally been taught. So you were originally taught to take the larger number, which is 15, and multiply it by 4. You line the 4 up below the 5. 5 times 4 is 20, so you write the 0, you carry the 2. 4 times 1 is 4, plus 2 is 60. And then if we check this, we could do the same as 4 times 20 minus 5. The reason why it's 20 minus 5 is because both of those are two really easy numbers to work with. So let's check this. So 4 times 20 is 80 minus 4 times 5 is 20, and 80 minus 20 is 60. You'll notice these two are the same, but they are completely different ways of looking at it. 20 minus 5 is 15. Again, we use those because they're easy numbers to multiply by. So if we look at the next one, represent the equivalent product 4 times 10 plus 5 as a repeated addition of 10 and 5, and then find the product. So we're going to do the same thing we did here, except this time with addition. So 4 times 10 plus 5. Distributive property. 4 times 10 is 40, plus 4 times 5 is 20, combine them, and we get 60. So if you look at the two newer ways to do it, not the standard algorithm, those are ways that you could actually do it in your head without having to write it out on paper and carry the two, and this way it actually makes more sense. So it shows the important property of being able to apply a multiplication to all parts of a sum in symbolic form. If A, B, and C all represent real numbers, then A times B plus C equals A times B plus A times C. So evaluate each of the product by using the distributive property to make it easier. Express 18 as a subtraction. Do not use a calculator. So we're going to split up 23 into 20 plus 3. 7 times 20 is 140. 7 times 3 is 21. Combine those and you get 161. That could have been really hard to do in your head otherwise. It asked you to do 18 as a subtraction. So what that looks like is 20 minus 2. 9 times 20 is 180 minus 9 times 2 is 18. And 180 minus 18 is 162. The distributive property can be used twice in order to multiply two-digit numbers. For example, find the product of 12 times 28 by evaluating 10 plus 2 times 20 plus 8. Show each step in your calculation. Do not use a calculator unless it is to check. So 12 is 10 plus 2, and 28 is 20 plus 8. So 10 times 20 is 200, plus 10 times 8 is 80, plus 2 times 20 is 40, plus 2 times 8 is 16. So we had to multiply every single part of the beginning number by every single part of the second number. 200 plus 80 is 280. 280 plus 40 is 320. 320 plus 16 is 336. You could have stacked each of those up, so 200, 80, 40, 16, and found 6, 8 plus 12, 13, so 336. The distributive property can also be used on expressions that involve variables. So express the following products as binomial expressions. Show each step in your calculation. So first we're going to do 5 times 2x. So 5 times 2x plus 5 times 3. 5 times 2x is 10x. 5 times 3 is 15. You can always stop and press pause if you want to practice these on your own as well. Next, we have negative 4 times 5x. So negative 4 times 5x and negative 4 times negative 8. But remember that you can always make this a plus negative. So plus negative 4 times negative 8. So negative 4 times 5x is negative 20x plus. When you multiply a negative times a negative, it's a positive, and 4 times 8 is 32. X times x plus x times 4. Well, x times x is simply x squared, and x times 4 is 4x. And finally, 5x times 2. Remember to always make a subtraction a plus negative. So now it's plus 5x times negative 7x. So 5x times 2 is 10x plus positive times negative is a negative. 5 times 7 is 35. X times x is x squared. If you want, you can rewrite it in order according to x's to be ascending. So negative 35x squared plus 10x. One common mistake students make is not realizing that the distributive property works for division as well as multiplication. For division, the property would look in symbolic form like if a, b, and c all represent real numbers, then b plus c divided by a is the same thing as b divided by a plus c divided by a. So express each of the following quotients as binomials in simplest form. Show your calculations. Some of your final answers will contain fractional coefficients. So this is the same thing as 8x divided by 2 plus 4 divided by 2. The reason why it is really important to rewrite it is to see that you are actually dividing everything by the denominator. So 8x divided by 2 is 4x, and 4 divided by 2 is 2. Next, 25x divided by 5 minus 50 divided by 5. Well, 25x divided by 5 is 5x. 50 divided by 5 is 10. Then we have 2x divided by 4 minus 16 over 4. Remember in the beginning it did say that you will have fractional coefficients. So 2 over 4 reduces down to 1/2 x, and 16 divided by 4 is 4. Finally, negative 9x over 12 plus 18 over 12. Both of these will stay fractions because you cannot divide 9 by 12 or 18 by 12, but they do have, they are not in their simplest form. So negative 9x over 12, they both have a 3 that goes into them. So 9 divided by 3 is 3, and 12 divided by 3 is 4. And the largest common number between 18 and 12 is 6. So 18 divided by 6 is 3, and 12 divided by 6 is 2. So negative 3/4 x plus 3 over 2.